Start with a right triangle. One of its corners is a perfect square corner. The side across from that corner is the longest one. We call it the hypotenuse. Label the two short sides A and B and the long side C. To find how these three sides relate, look at one clever picture. Here is a large square. Each side has length A plus B. Now place 4 copies of our right triangle into the corners. Look at the gap they leave in the very middle. It is a square built on the hypotenuse, so its area is C squared. Keep the same 4 triangles, but rearrange them. This time the leftover space is 2 smaller squares. Their areas are A squared and B squared. The big square and the 4 triangles never changed, so the 2 leftovers must be equal. And that is the Pythagorean theorem. A squared plus B squared equals C squared. Let's check the theorem on a grid with a real triangle. From the first point to the second, we move 3 across and 4 up. The straight line joining the 2 points is the hypotenuse. 3 squared plus 4 squared equals 9 plus 16. That is 25, which is exactly 5 squared. So in any right triangle, the squares of the 2 legs add up to the square of the hypotenuse. Next, we'll use this very idea to measure the distance between any 2 points on the plane.